This is the world's most advanced attack helicopter, the Apache Longbow. Designed with one purpose in mind, to hunt down and eliminate enemies. It is known as the tank killer, and it is also the fastest, most elusive attack helicopter in the world. This workhorse of the United States Army is now in use by 13 countries and regions worldwide. Since its inception, its remarkable capabilities and exceptional performance in the field have consistently earned it top place in global attack helicopter rankings. The construction of such a world-class war machine demands an equally exceptional manufacturing facility. Welcome to Boeing's Apache factory in Mesa, Arizona, spanning a massive 2.1 million square feet, approximately the size of 7 city blocks. This center for research and production enjoys the wide open spaces and virtually constant flyable weather of Arizona's Sun Valley. Run under stringent security, the Mesa factory produces 40 Apache helicopters each year. These high-tech flying machines, each one handcrafted right here in this factory without the aid of robotics, now number in the thousands and are deployed worldwide. The Apache, weighing in at around 8 tons, consists of numerous components, all assembled by hand by skilled technicians. The assembly team of 160 members is dedicated to the meticulous construction process, fully aware that pilot safety is directly linked to the quality of their work. The Apache is an attack helicopter designed to withstand enemy ground fire, strike with blinding speed, and deftly escape from perilous situations. As stealthy as an assassin, it's equipped with deadly weaponry and cutting-edge technology. The manufacturing journey begins with raw frames. Up to 6 arrive each month. The construction process starts with installing 2 potent engines delivering a total of 3,600 horsepower. Next in line are the Hellfire missiles capable of penetrating nearly 2 inches of armor from a distance of about 5 miles. A powerful chain gun and highly sensitive targeting system are then added, followed by a state-of-the-art radar system. By the time it rolls out of the factory, each Apache tips the scales at over 8 tons. An Apache undergoes assembly at 15 different stations within the factory, a process that takes about 3 months. The US military's demand for an attack helicopter like the Apache dates back to the 1970s, in response to the shortcomings of helicopters at the time. The Huey, a transport helicopter, could only fly during the day and was an easy target for ground fire. From 1959 to 1975, over 5,000 Hueys were shot down in various conflicts. Post-war, it became clear that a new type of helicopter was needed, an attack helicopter, designed specifically for armed combat capable of night flights, surprise attacks, weathering harsh conditions, and withstanding enemy fire. Fulfilling this tall order is the ongoing challenge faced by the Boeing factory. The construction of the Apache Longbow starts with outfitting it with a tough armored shell. Given this is a low-altitude assault helicopter, assembling armor components takes place across the first 5 stations in the production line. Equipping the Apache with its state-of-the-art armor begins with a surprisingly low-tech procedure: good old-fashioned riveting. Thousands of rivets bind together the individual metallic sections of the Apache's exterior shell. The more rivets employed, the more robust the aircraft becomes. This makes the daily 8 to 9 hour riveting routine a labor of necessity and love. The Apache shell consists of lightweight aluminum plates. This not only enables the Apache to fly faster, but also enhances its maneuverability. Next comes the application of the armor. In a quest to make the Apache as bullet-resistant as possible, the aircraft's outer shell receives a substantial upgrade. The protective casing around the specially designed fuel tank is of paramount importance. If this component were to be hit, the entire Apache helicopter could ignite mid-flight. Yet the factory has come up with an ingenious solution to safeguard the Apache and its pilots. At the 6th station of the assembly line, technicians coat the inside of the aircraft with 3 layers of bullet-resistant protection, thereby providing isolation from external projectiles. This seemingly ordinary packing foam is a bespoke material known as bulletproof foam plastic, which is highly effective at absorbing the kinetic energy of impacts. The subsequent layer of protection is a custom-designed resin applied over the bulletproof foam plastic. This resin filler acts as a barrier to potential air pockets that could potentially fuel a fire should the Apache's fuel tank sustain a hit. Then, while the resin is still moist, the technicians overlay it with the final layer of bulletproof material. This material is none other than Kevlar, a synthetic fiber that's 5 times tougher than steel and commonly used in the manufacture of bulletproof vests. On the Apache, it serves as the fuel tank's defensive layer. Applying this armor is an arduous, time-consuming task, made all the more challenging by the strong smell of the chemicals involved. This triple-layered protection wraps around the entire underbelly of the Apache. The armor is incredibly thick, essentially serving as the pilot's shield, but even with these safeguards, the Apache has its vulnerabilities. Its 2 main fuel tanks, filled with approximately 99 gallons of high-octane fuel each, could be ignited and set ablaze if a projectile manages to penetrate the armor. That's why it has another safety measure to circumvent fuel tank explosions upon impact. The rubber used to make the fuel tanks incorporates a unique self-sealing compound. Remarkably, even if it's punctured by a 30mm caliber bullet, it can automatically seal itself. Next, technicians maneuver the sizable fuel tank into a compact space. They begin with the dusting of talcum powder before securely strapping the tank and slotting it in. Above the fuel tank, they are implementing safeguards for the pilot. Their goal, to transform the cockpit into a veritable fortress, each component including the seat constructed from layered Kevlar. This material renders the cockpit bulletproof from all angles. Even the cockpit glass is bullet resistant. Impressively, the cockpit can endure a direct hit from weaponry up to a 23mm caliber. In dire circumstances where the Apache sustains extensive damage and the pilot must eject swiftly, detonation cords can ignite a minor explosive, shattering the side windows for the pilot to parachute to safety. Back at the factory, every Apache spends 3 days at each station. This process is known as a pulse line assembly. Each time one helicopter advances, the rest follow suit, moving to the next station. However, this transition is entirely manual, relying on the workforce. The Apache, thought to be the world's fastest helicopter, can rapidly infiltrate and withdraw from the battlefield amidst enemy fire. It can zoom from 0 to 62 miles per hour in a mere 4.7 seconds, outpacing even a Porsche sports car. However, the Apache tips the scales at 8 tons, necessitating a substantially powerful engine. At the 10th station of Boeing's Apache factory located in Mesa, the engine flexes an impressive 1900 horsepower, roughly on par with a diesel locomotive. This durable turboshaft engine sees common use in tanks, trains, ships, and Black Hawk helicopters. Although General Electric manufactures the basic engine, Boeing personnel install additional components such as fuel pipes and external wiring. Then a crane hoists the 450-pound engine into place. An installation process kept simple by limiting connection points between the engine and the fuselage to 3. This simplicity ensures that engine replacements on the battlefield can occur in just half an hour. Each Apache houses 2 engines, propelling it to a blistering top speed of 200 miles per hour. The engines are positioned on either side of the fuselage, with one serving as a reserve, engaged only when the other fails. Remarkably, even if an engine sustains a hit, it can power the Apache for an additional 40 minutes. But such power comes at a price. The engines heat up significantly, making the helicopter a potential target for heat-seeking missiles. To counter this, the technical staff have devised a unique suppression system, the particulars of which are a closely guarded military secret. At its core, the system enables the hot exhaust gases to intermingle with the Apache's surrounding cooler air. This process cools the exhaust pipe's vicinity to about the same temperature as a hairdryer, making the helicopter more challenging for heat-seeking missiles to track. If an engine should catch fire, automated shutters will close off, blocking air intake and extinguishing the flames. Assembling an Apache helicopter involves an array of parts, millions of them, stored in the factory's distribution center. Yet the task of sorting through these components day and night falls on a small team of technicians. A computer system aids this process, sorting through tens of thousands of boxes to pick the required parts, which are then sent off to various workstations by the staff. Forward to around day 25 and the Apache reaches its 11th station, where power units and protective measures are installed. However, the primary mission of an attack helicopter is offense, so it's time to arm the Apache. The Apache features 3 primary weapon systems. The Hellfire missile can pierce 5 centimeters of armor from a staggering 8 kilometers away. Then there's the Hydra rocket, each capable of launching 19 individual rockets. For closer targets, pilots turn to the 30mm chain gun with a range of 1.6 kilometers, capable of spitting out 1,200 rounds at a rate of 600 per minute. Once connected, the chain gun tracks the pilot's gaze, aiming wherever they look. By this stage, the Apache is decked out with armor engines and weapons. The US military identified a shortfall in the Apache. It lacked a modern computer system to share information with ground forces. Starting in the early 1990s, they set out to revamp this high-tech system, scrapping 1,200 switches, dashboards and control sticks in favor of a fully digital cockpit, replete with a potent new computer and displays for targeting radar and night vision. With the introduction of such high-tech equipment came a wiring headache. The first step for the technicians was to install an avionics bay for the housing of all the wires. The Apache's total wiring length comes to an impressive 13 kilometers, equivalent to the total length of wiring in 44 Eiffel Towers. Technicians meticulously connect wires and consult instructions, leaving no room for error. With 1,500 junction points on an Apache helicopter, each wire must undergo testing for faults. Connecting the wires takes around 4 hours, but testing them a mere 25 minutes. Once all the wiring checks out, the Apache is ready to assume its role as the aerial eyes for the ground forces. The assembly team is in the process of outfitting the nose of the most formidable attack helicopter on the planet. The targeting system of this turret, fixed on the chopper's nose, comes equipped with a video camera, a telescope, night vision sensors, and a robust radar mechanism installed on the primary rotor. Initially, the team places 3 computer systems in each of the avionics compartments on both sides of the helicopter. These computers are dedicated to handling all the data that populates the screens within the cockpit. Following this electronic display, units are installed within the cockpit. And finally, with the aid of a boom, the nose is secured into position. The Apache's nose plays a crucial role in navigation, containing a state-of-the-art targeting system that extends the pilot's visual range beyond 20 kilometers. The entire turret can swivel 120 degrees to either side. The upper portion of the turret houses a camera and telescope for the gunner's daytime operations. However, nestled at the bottom, a night vision sensor ensures that the Apache can engage enemies with the same ease at night as it does during the day. Through the onboard camera and sensors, pilots can view live imagery on the cockpit screens, and from their visors, they receive thermal imaging of flight conditions, including data like speed, altitude, direction, and target location. The latest Apache models are equipped with an even more potent tool, the Longbow radar system. Over the battlefield, this radar can sweep a 360-degree field in the air and a 270-degree field on the ground. It has the capability to analyze whether approaching objects are tanks, trucks, or aircraft, and even distinguish between friend and foe by cross-referencing radar information with available data. Given its strategic placement atop the Apache, the hemispheric radar can surveil the surroundings while keeping the helicopter concealed. It allows for opportune missile launches and rapid exits without enemy detection. Back in the Apache factory at Boeing's Mesa facility in the US, at Station 10 of the assembly line, a 10-ton crane is used to hoist the tail rotor to its precise position. Without the tail rotor, a helicopter would simply spin uncontrollably. The tail rotor provides the necessary counterforce, and by adjusting its power, pilots can maintain control over the chopper. However, the noise produced by the rotor could potentially give away the Apache's position from quite a distance. The solution is to equip the Apache with a cruciform or cross-shaped double rotor. By altering the tilt angle of each rotor, their respective noises can counteract one another, making two rotors much quieter than one. Now the Apache is ready for the installation of the final component necessary for liftoff the main rotor. The blades of this rotor, weighing 280 kilograms, allow the Apache to hover mid-air. To handle such a massive weight, they must be rigid enough to withstand the stress of various acrobatic maneuvers. As a result, a fixed-style mast rotation hub is adopted. The technicians mount the rotor on the hub, securing it to the helicopter using 4 V-brackets. The attachment of the rotor in the hub is completed with just 4 bolts. The drive shaft that propels the rotor runs through the hub, allowing it to absorb vibrations generated by flight movements. This hub design ensures that the Apache can safely perform dives, rolls, or sharp turns. These control features were validated in the 2001 Afghanistan conflict, where it was found that the Apache could still fly for 40 minutes without any lubrication and return to the factory. The last piece to be installed on the Apache is the rotor, worth over $60,000. Each blade of the rotor measures 6 meters in length. During flight, the rotor of the Apache spins at over 1,200 revolutions per minute, providing the necessary lift. To withstand artillery fire, the attack helicopter's rotor must be extremely durable. It is made from titanium, a material harder than steel, but half its weight, and it does not corrode or rust. The leading edge is made from stainless steel. Titanium can withstand extreme cold and heat, as well as repeated impacts without cracking. Even if bullets pierce through the blades, it doesn't affect the Apache's normal flight. Half an hour later, the rotor installation is complete. The Apache must then undergo a series of tests before it's ready for delivery. Technicians check the components for any flaws, and both the pilots and technicians balance the rotor to ensure it rotates perfectly. Next, they run the engine at full speed to test all the internal systems. Boeing's test pilots then begin airborne testing, which includes vertical takeoff and landing, sideward flying, reverse flight, and hovering. Once it passes the hovering test, it is ready for the maiden flight. The final challenge is to test the maximum acceleration feature, and that concludes the 3-month assembly process of the world's most advanced attack helicopter, the Apache Longbow.
Let's take a look at the production of the Apache AH-64. In the second half, I'll also show you the Bell factory. Leave me a comment on what you think of the Apache and Bell helicopters. The Apache AH-64 has been designed to protect the crew. Every inch of the body engineered to endure hits from 12.7mm caliber rounds, while the underside rotors and cockpit can resist rounds of double that size. To make this angel of death takes a factory like no other. Boeing's Apache plant in Mesa, Arizona. The size of 7 city blocks, it's a vast factory complex and has 2 million square feet of research and manufacturing area in Arizona's Valley of the Sun. The choice of location is important. Good weather and plenty of space to design, build, test, and fly the most successful attack helicopter in the world. Workers manufacture an average of 32 Apaches a year. In addition, Boeing repairs and renews aircraft returning from active duty. They may be refitted or modified into modern specifications. To turn an Apache from raw and naked fuselage to battle-ready killing machine takes 160 workers 3 months. And it's all done by hand, no robots here. People are better at negotiating the tight spaces inside this framework. At the center of the factory is a 15-stage production line. Known as a pulse-moving line, there are no chains, rollers, or moving walkways to advance the helicopters from one production stage to the next. Instead, the Apache is physically moved by hand, as work on each station is complete. Timing is critical, each Apache must be moved forward in unison to completion. After 5 days in each station, it moves to the next stage in construction. Starting with the airframe, fuel tanks, cockpit, engines and rotors, electronics and sensors, and finally weaponry, turning this pile of metal into one of the deadliest brands at the military's disposal. First stage sub-assembly. This is where the metal that makes up the skeleton of the Apache takes its shape. It's no simple task, and it takes 5 of the 15 workstations to turn aluminum into airframe. Aluminum means low weight, high speed, and maximum agility for this high-tech flying machine. But the start of this build is low-tech, a process known as smashing rivets. Up to 100,000 rivets will be needed to secure this first stage of the build in place. The workers take their time, they know that more rivets equals more strength. But strength isn't enough. Above the battlefield, this machine will face flak and enemy fire. To return from battle, the entire airframe must be reinforced with body armor. The exterior of the helicopter is covered in flat structural surfaces, reinforced by a protective covering. From nearly every angle, the opposing projectile will face an armored blunt surface, which it must breach in order to damage the craft. One of the most vulnerable parts on any vehicle are the fuel tanks. To protect them takes precision engineering and some very unusual materials. This ballistic foam has been specially designed to absorb impacts. It's made from sandwich-like layers of glass in polyurethane foam that drastically slows down the speed of projectiles and absorbs their energy. The foam has been pre-cut to encase the fuel tank like a 3-dimensional jigsaw puzzle. Next, a special resin is mixed on the factory floor. The resin is designed to prevent air leaks and seals the tank in case of a bullet strike. Applied over the ballistic foam, it will also prevent any fuel from escaping should the tanks take a hit. A fuel leak on any helicopter could start a deadly fire. Finally, on top of the resin, a last layer of defense, Kevlar sheets. 5 times stronger than steel, Kevlar will stop bullets in their tracks and keep shrapnel from penetrating the vulnerable fuel cells. Kevlar is so effective it's used by the US military and police to make bulletproof vests. Every Apache comes equipped with 2 rubber fuel tanks. Failsafe systems are key to the endurance of this machine. Take one out, and there's a backup. The 2 fuel tanks will be loaded with 300 gallons of highly flammable jet fuel. But they're not unprotected. The rubber lining contains a special reactive agent that expands on contact with fuel. Should there be a leak, this cell will seal the hole itself. The cell is lifted into place. It's hard work, and the crew must ensure that the fuselage is free of any foreign debris that might puncture the rubber. Now, this mean machine is virtually impenetrable. The armor on the underside of the Apache is so effective that in combat, pilots will even turn their helicopter's belly to face the enemy fire. The underside acts as a shield for craft and crew. But there is one final area that needs serious reinforcement. The flight center of the Apache, the cockpit. The cockpit is a reinforced bulletproof chamber with glass up to 2 inches thick. The bulletproof side windows are surrounded by detonation explosives. In the event of an emergency, pull the trigger, and the windows fire out with explosive force, providing a quick exit from the cockpit. The Apache has 2 cockpit sections. The pilot sits in the rear, and the gunner sits in the front. The rear section is raised above the front section, so the pilot can see clearly. A transparent acrylic blast shield is mounted between the fore and aft sections, separating the 2 pilots. If one pilot takes a hit, the other can survive and fly to safety. But should the Apache go down, there is one final line of defense. The areas fore and after the cockpit are designed to buckle on impact. Like a crumple zone in a car, they absorb the force of collision and carry it away from the crew. The cockpit is the command center of the Apache, giving both pilots instant access to flight, navigation, and weapons data. There are 5 different displays in approximately 25,000 different switch combinations available to the pilots. Weapon systems, navigation, radar, communications, aircraft survivability, night sensors, day sensors, manned and unmanned teaming systems are all at their disposal. To control them take some high-tech electronics. The electrics start out here, Station 8, the company's electrical strategic manufacturing center, a different room in Boeing's vast Apache plant in Mesa, Arizona. It may not look like a helicopter, but each of these wiring boards is the exact dimensions of an Apache. There are 11 miles of wiring in every Apache Longbow, so each wiring harness must be carefully laid out to the correct length and path. The wires are secured together in bundles to make them easier to thread through the Apache. Next job, connecting the cables together. A special heat gun secures and waterproofs each electrical connection. known as splicing. It's a way of connecting different wiring systems without risking loose connections. One loose connection could mean death for the crew and failure of the mission. Next up, the wings. It may seem odd for a helicopter to have wings, and in fact the Apache stubby wings do increase the drag coefficient, reducing the helicopter's aerodynamics. But these wings serve a vital role. They're support brackets for fuel tanks and weapons. The wings also reduce aircraft-induced vibrations during flight. This makes the weaponry easier to target. To fit the wings, workers use a precision hydraulic lift known as the wing tool. The tool holds the wing in place and straight while it's bolted tight. It also stops the heavy wing from straining the support pins during installation. Further bolts secure the underside of the wing. A special wrench is used to ensure that the torque is not too tight.